Welcome to the lecture of atomic structure. In this lecture, we are going to discuss what is the structure of atom, then how electrons are organized in atom. So almost all fundamental things regarding atom we are going to discuss here. But the first question is, what is an atom? So we are starting out from beginning and end will be at a deep configuration, electronic configuration. So first question, what is an atom? So atom is defined as it is smallest particle of an element possessing all chemical properties of that element. So from this definition, it is very clear that what is element. So we have to discuss now what is an element. But rather that I should go this way, that how this universe is made up of. So with our present knowledge, say why I am saying our present knowledge, because now scientists are accepting there is tremendous matter, categories of matter that we are not aware. So whatever our knowledge is there, that is hardly 5% about this universe that is given by scientists. So if scientists are having 5% knowledge, then just consider what I should have that knowledge. And with that knowledge, I am going to teach. So first thing, we are dividing this part, whatever on earth. Let us consider in case of earth. So it is mixture, compound and an element. What is mixture? Mixture can be mixture of any two elements, one element and one compound, or two compound. And like that, probabilities are there. That means more than one component should be there. So it may be 10 mixtures, 10 compounds mixture, 10 elements mixture, anything you can consider. But minimum two components are required. Both components must be either one is element, one is compound. Both may be compound or both may be element. There is no fixed proportion in case of mixing. Say for example, I will take 1 milligram common salt. That is called as sodium chloride. So 1 milligram common salt in 1 liter water. I may take 10 gram common salt in 1 liter water. So whatever the considerations are there, they are considered as mixture. Now from mixture, we can separate out compounds or elements with comparatively easier method. I am using word comparatively. Say for example, I am having salt solution. That is our seawater. So we can take seawater, we can evaporate. On evaporation, water will get lost, and whatever the remaining, they are a mixture of salts, predominantly sodium chloride, but apart from that, magnesium chloride, calcium chloride and variety of salts may be there, depending upon where is the sea and what are the effluents. Then effluent means, say for example, if we are near Mumbai, then chemical zone is there, and a variety of chemicals, they are also entering in the sea. So in traces, this type of chemicals will also get there in the salt. So we can separate out water from salt, comparatively easy method. Now in case of compound, the separation is not that easy. I am not saying easy, it is not that easy. But in case of compound, there is fixed proportion of combining element. Say for example, I am carrying out electrolysis of water. You are aware of the formula H2O. So let me, you will get automatically afterwards knowledge. Just I am giving you example here, therefore I am giving some data. So suppose I am decomposing water by passing electrical current. Then water will give me that whatever the amount, that is give me in the proportion of 1:8, 1 part of hydrogen by weight, 8 part of oxygen by weight. In that ratio, I should get the things. So there is fixed ratio between combining element in case of compounds. But what is an element? So whatever the compounds you can able to separate out. On separation of compound, we have to carry out various method. That is called as decomposition. You are aware of composition, that means to join things together. Decomposition, to make separate. So here we are getting decomposition of the substance. Say for example, just now I told that water, on passing out electrical current, little bit acidified or salty water should be required because conductance should be there. But predominantly on electrolysis of water, we are getting hydrogen and oxygen. This is called as electrical decomposition. Whereas if you are decomposing calcium carbonate, okay, can we carry out one simple exercise? Just I am going to write here. This substance that is called as calcium carbonate. We are going to heat it. This is the symbol of heat. That means we are heating out strongly. Say for example around 600 degrees Celsius if you are heating out. But what is calcium carbonate? From where to obtain? It is limestone. Or even we can consider powder of marble and chalk. Chalk means not present day what chalks are there, dust-place chalk, etc. They are not there. But naturally occurring part is there, that is called as chalk. So that everything consisting of calcium carbonate. So I am heating out calcium carbonate strongly. I will get here calcium oxide plus carbon dioxide. Now in front of carbon dioxide I have to put here an arrow, upward arrow, that is indicating this is a gas. So this is called as thermal decomposition. Why thermal? Because we are heating out and then substances are getting decomposed. So this decomposition is called as thermal decomposition. Now here this calcium carbonate, that is called as limestone. This is what we are obtaining here, that is called as quicklime. So like that substances are there. Now this is something we are talking about thermal decomposition. So we are having electrical decomposition method, we are having thermal decomposition method. Sometimes we are using a method that is called as chemical decomposition. But it is not actually perfect, but we can consider that. Say for example, iron oxides are there. Generally we can consider Fe2O3, but variety of iron oxides are there. If they are reacting with carbon, then we are getting iron. This reaction is not balanced. I will teach afterwards balancing out. And carbon dioxide is released. So this is actually here we are considering under chemical decomposition. So like that variety of reactions are there. They are there for decomposition. Now when we are decomposing out the substance and finally we are getting something, say for example here I am getting iron. In previous reaction I was getting there either hydrogen or oxygen or both things. So like that things are there. On further decomposition method, that substance should not undergo decomposition. So whatever you are going to carry out on iron, iron will not undergo further decomposition. Therefore, iron is called as an element. Same way, hydrogen is called as an element. Oxygen is called as an element because they are not undergoing further decomposition. So, now part of definition we discuss, that is what is called as an element. The smallest particle of that element possessing all chemical properties of that element, that is called as an atom. But this is all hypothetical concept. In Europe, there was a person named as Democritus. He proposed the theory of atom in Europe. In India, similar theory was discussed in the literature that is called as Vaisheshik Darshan, given by a great person named as Aulukya, but later on he is famous as Kanad. So the concept of atoms, they were there. But again keep in mind, they were hypothetical concept at that time. The real change in this method was carried out by a great scientist that is called as Dalton. Dalton first time given a fantastic data what about atom. But I am always having doubt that he might have confused about atma in Sanskrit and atom in Greek. or whatever that European language, what is the principle? He says atom is smallest indivisible part of an element possessing all chemical properties of that element. Secondly, one cannot convert atom of one element into atom of other element. Third, one cannot destroy existing atom. Next, one cannot create new atom. So like that principles are given by Dalton. But yet, there was lot of confusion whether atoms are there or not. Because debate was there. And in science, these type of debates are welcome. The literally change was occurred in development of modern physics. Particularly after 1896, whatever the developments are there, they are considered under modern physics development. So now we are focusing in next part about modern physics.